So the new addressing modes you have are register, register list. You have like post incrementing and like all sorts of weird stuff. So what can end up happening here is we can have register addressing, right? So what does that mean? That means when we just use registers. So that's here. Register addressing is something like add, R2, R0, right? We just use registers. And so I also have this, when I use instructions, I also have like an optional second operand, which means that if I have only two registers, like add, R2, R0, it means I'm adding R2 and R0 and storing the value in guys, quiet. I'm adding R2 and R0 and I'm storing the value in R2. Right? That's what, when I only have two registers, that's what it means I'm doing. Or a register intermediate. Right? So that's register addressing. Register list is actually going to be when I have these braces here. Do you see these braces? So what happens is that with a push and pop instruction, I can actually push or pop multiple things in one instruction. Right? So this is actually saying push R1, R2, and LR. Okay? That is section 3.3.2. So a good question that kind of trips people up is when I ask questions about the stack and what order things are pushed and popped on the stack, right? So let's go over that. Okay, here. So what happens here is that if I have a register list and I push, R1 gets pushed first and then R2 gets pushed and then the LR. Okay? So it goes from left to right in order of what's pushed. Okay? But what I can also do is I can also if I do like a push and I have a list, I can actually push register 1 through 5 by doing it like this. Okay? So that means push 1, 2, 3, 4, and 5. Okay? From left to right in that order. Okay? So that's another tricky thing. So if you have a stack question, remember that. There's obviously index addressing. So one thing about index addressing, right, is that's what I have those braces for. I have those braces to describe index addressing. But I can also have different things, right? So what I can do is I can have index addressing in there. I have R1, but if I put a 4 here, what it's going to do is it's going to look for R1 plus 4, the address described by R1 plus 4. Does that make sense? And then here, it's going to be, this one's going to give you 2 separate values. So it's going to give you 2 different loads, right? So what it's going to do is it's first going to load R1 with R1 plus 4, and then R0 with R1. That's what that little exclamation point means. So you can do some really tricky stuff. You can really condense your code. Okay? And then here, this one is post-indexing, right? So this is pre-indexing, right? So what this does is it adds 4 to R1 before it checks for that value, right? Before it goes to that location. This one will go to that location and then add 4 to R1. All right? So you can actually use this to like traverse an array. Does that make sense? Or like to traverse some sort of like memory locations. So I can, if I go through a loop and I continually call this instruction, R1 will get continually incremented. You see that? So it eliminates the need for me having to have an add instruction. So now here, I can put in 2 instructions inside parentheses, and that will add them before going to that value and checking them, right? So I can have like one that's a counter, right? And one that's my address, and I can iterate off of that. And then here, you can also do shifting, right? So I can create even more complex instructions. So this is kind of self-explanatory. What it's saying is that R0 is going to get the value that's located at R1 plus R2 shifted.
Wait, what is it up for instead of 2?
Oh, it's shifted by 2. It's shifted by 2 multiplied by 4, right?
Yeah. Okay.
So that allows you to, so we use this, right, because we say that, oh, if we're traversing an array of 16-bit values, right? If we're traversing an array of 16-bit values, when I increment R2, I can just left shift this. If I'm traversing an array of 32-bit values, every time I increment R2, it'll take me to the next 32-bit value. Does that make sense? Do you see why? Because it multiplies it by 4. Multiplies the address by 4. So if R1, so think about this. If I have an array, right? If I have an array and R1.0, each of these are 8 bits, right? But I know that this array stores 32-bit values, right? So 1, 2, 3, 4. So that these are 2 separate values here and here, right? So this is some variable 1, right? This is one variable stored in 4 memory locations on the ARM processor. You agree? This is another variable stored on that, right? So what happens if I add R2? If R2 is sort of my index, right? If I use R2 as an index to traverse this array, right? In order to traverse by increments of 4, if I multiply this by 4 every time I increment R1, like if I want to look at the 0th element, right? This is element 0, right? This is element 1. When R2 is 0, right, it points to the proper location. When R2 is 1, R1 will point here. Does that make sense? So I can traverse an array of different sized elements. That's what that instruction is for. Okay? Alright, and then we have PC relative addressing. Obviously, that's all of these. Right? Those are pretty straightforward. This describes a flexible second operand. Right? So I explained that before. If I have some instruction that only takes 2, right? So you see that I can write the same code in multiple different ways because an add R0 R1 is the same as saying add R0.
It's fine. It's good. It was like
Okay. Yeah. So those two are identical. Yeah.
We assume instructions take up 4 bytes, right?
I think so. Yeah.
Isn't it dumb?
No, it's dumb actually. So I think it's supposed to be 16.
So if you want to go from one instruction to the next,
You would do 2, right? You would left shift by 1. Let's see.
wait, but if you're adding like to the PC, you add by like 2 then?
Yeah, the PC gets incremented by 2 each time. Let me see. Yeah, that should be right. Yeah. Any more questions?
Just PC plus 2 and I'll go to the next one.
I believe so.